For the second example here, let's consider D4, the dihedral group of symmetries of square, as the group of permutations of square. Now what we do, we create a point P here on this main diagonal and some point Q here in between this square. Now for these 2 points, we need to calculate the stabilizer of the point P as well as the point Q in the given figure. Now, because first of all, you should know what all entries are there in D4. Then only you are able to tell the answer, which is the permutation. In D4, we know we have rotation by 0 degree, rotation by 90 degree, rotation by 180 degree, rotation by 270 degree, and then reflection by on this horizontal direction, right? Then reflection on this vertical direction, then reflection along this main diagonal, and then reflection along this other diagonal, right? So these 8 elements are there in this group D4 of symmetries of square, right? Now what we are required to calculate the stabilizer of this point P and Q in the above figures, right? Now the stabilizer would be what? According to definition, the stabilizer of the point P in the group D4, it would consist of all such phi's which belong to D4, such that when you apply phi onto P, it will give you back P, right? So you see R0, what is it? It is the rotation of the square by 0 degree. So that means we are not doing anything to it. So that means the point under this composition R0, rotation R0, it would remain as P. So definitely this R0 would be member of the stabilizer, right? Again, R90 would not be there, R180 would not be there, R270 would not be there, because in each of the cases, in the first case, P would come to this position when you apply R90 to it. When you apply R180, it will come here and here. So basically it will go here. So this is not the same as P. Again, when you apply 270, P will go here first, then here, and then here. So finally your P would come here, which is not the same position as that of P. So therefore all these 3 are rejected and they will not come in our set or subgroup the stabilizer of P in D4, right? Now what about H? If you reflect it horizontally through this horizontal x-rays, so P would come at this position. So obviously this would not be there. So therefore, what about this V? If you reflect it along this vertical axis, so your P would come at this position. So obviously here also this V would not be present in our stabilizer. What about D? So if you are reflecting it along this main diagonal, so that means after reflection P would come to this position only, right? So therefore this point is keeping P as fixed. So therefore this would come under our set of stabilizer, right? And what about this D dash? For the D dash, we have this as the D dash, the other diagonal, right? The straight line. Now if you are reflecting it along this diagonal, so this P would come to this position here, right? So therefore it is not keeping P as fixed, so we will not take this one also. So therefore the stabilizer would contain 2 elements only. One is this identity permutation, which would obviously be there because you know it, R0, and I have also given you the reason for the same, why it is there in the stabilizers group, stabilizer of P within D4, and there we would have D also present here. What about the point Q? What would be the stabilizer for the point Q? So here the stabilizer for the point Q would be such that it will keep Q as fixed, right? Phi of Q would be Q. So what about R0? If you apply rotation of 0 degree, so basically we are not doing anything to it, so Q will be in its place only. So therefore this R0 would definitely come in the group of stabilizer. Now what about R90? R90, if you apply R90 to it, this Q will come to this particular position, correct? If it will come to this particular position, then Q is not same as this. So therefore this R90 is not there in our group of stabilizer. What about 180? When you apply rotation of 180, this Q will come first of all to this place and then to this place, right? So therefore the positions of Q, both the Q's, they are not same. So therefore this R180 would also not be present in our stabilizer of Q. What about 270? For 270 it will first go here. For 90, for 180 it will go from here, and for 270 it will come to this position. So that means this position and this position, they are not the same. So in therefore we have our 270 not a member of the subgroup of stabilizer of Q. What about H? So what we are doing, we are reflecting it along this particular line. So if you reflect it along this particular line, so you would have Q somewhere here, right? So this position is not the same as this position, so therefore this H would not come in our set of stabilizer. What about V? So if you reflect it along this vertical line over here, so this Q would come to this position, and this position is not the same as this position, so therefore this V is also not a member of the group of stabilizers. What about D? If you are reflecting it along this main diagonal, then this Q would come to this position. So obviously the positions, they are different, so therefore D would also not be there. What about D dash? If we now rotate it like this Q would come to this position, and both the positions, they are not the same, so therefore this D dash would also not be present in the group of stabilizers. Hence we are only left with the identity permutation, which is a member of the stabilizer of Q under D4. So I hope you understood how to calculate stabilizers of different elements within a group, right? We have understood it thoroughly through two different examples of different kind. I hope you understood this concept well. Well, that is it for this video. Thank you for watching.